Hi everyone. In this video we are going to discuss this result. So what we have a function f from x to r where xd is a matrix space, getting, and r with a usual distance. So they have given if f of x naught greater than 0 for any point, some point x naught belongs to matrix space. If its image is positive, then in some neighborhood of x naught also we will have positive values. Okay, so let me draw the diagram so the picture will be clear to us. So what we have such a matrix space xd, okay, and we have a second matrix space rdu, usual distance. So you know at the middle we have 0, 1, minus 1, like that, getting. We have a function f from x to r. So for some point x naught, so x naught is image is positive, getting. So its image will be, it can be here, which is positive. That means in the right hand side of 0, and this is suppose f of x naught. So we have to prove that in neighborhood of x naught, getting, neighborhood of x naught. So we can find some delta. Okay, we can find some delta such that open ball with center x naught, radius delta. So if you take any point from this neighborhood of x naught, its image will be again positive. Its image is greater than 0. So this thing we have to prove. Okay, so let us start with the given information. Let me mention here. We have the most important information is f of x naught greater than 0. So you can mention here xd is a matrix space, f from x to r is a continuous function, getting, it is a continuous function. This is also so much important thing they are given, and f of x naught is also greater than 0. And what we have to prove? We have to prove this thing. So the second important information is f is continuous. Let me mention, we have f from x to r is continuous. So the function is continuous on x. That means it is continuous at each point of x. So therefore it is continuous at x naught also. So therefore f is continuous at x naught. So we are familiar with epsilon delta definition of continuity, that is for given epsilon greater than 0, there exists delta greater than 0 such that d of x naught less than delta implies rho of f of x naught less than epsilon. So that definition I am going to use here. So we start with for given epsilon greater than 0, that means for any arbitrary epsilon greater than 0. But see, I am going to consider epsilon is equal to f of x naught. Since we want epsilon should be a positive real number and f of x naught is also a positive real number. So that's why I am choosing epsilon is f of x naught. I can continue the definition. There exists delta greater than 0 such that d of x naught less than delta implies, see, the domain has metric d, but in codomain we have a usual metric, that means mod. So mod f of x minus f of x naught less than epsilon, getting. So let me mention, we have space, so let us use, okay. So therefore, see, distance between x and x naught is less than delta. Distance between x and x naught is less than delta. That means that point x lies inside the ball with center x naught, radius delta. If this distance is greater than delta, then we say the point lies outside. But here we have a distance less than delta. So we can mention x belongs to the ball with center x naught, radius delta, implies. See, we are familiar with one result. So let me mention here, that result is mod a less than b if and only if minus b less than a less than b. So this result I am going to use. This is our a and epsilon is our b. Let us use this result. So what will we get here? Minus epsilon less than f of x minus f of x naught. So we have a minus sign here, less than epsilon. See, actually 3 sides it has, minus epsilon, middle one and epsilon. So the last one is not required. So let us omit that part. So minus epsilon less than f of x minus f of x naught. See, now what I'm going to do, I'm going to shift this f of x naught on this side. So we will have f of x naught minus epsilon less than f of x, right? But do you remember the value of epsilon? Epsilon is nothing but f of x naught. So let us put the value of epsilon there. So we will have f of x naught minus f of x naught less than f of x. So these two terms will get cancelled to each other. So 0 less than f of x, that is the same thing we can write in this way. X belongs to B with center x naught radius delta implies f of x greater than 0. So that means if you take any point from this ball, its image will be positive. So this thing we proved. Okay, the same thing we have written in this way. So the proof is over. Make a screenshot of it, then we will stop. Thank you. See you.